So students, in the last video we have discussed about the parallel plate capacitor, the cylindrical capacitor. We have calculated their capacitance. Today in this video we will discuss about the spherical capacitor. Spherical capacitor will consider a spherical cell like structure, and inside this spherical cell, let's say another sphere. Okay, another sphere, maybe solid, maybe hollow sphere is there. Let's say this is of radius A and this one is of radius B. The outer cell is of radius B and the inner cell or inner solid sphere is having radius A. Now let's say the inner sphere is charged positively. Inner sphere is charged positively and the outer sphere is charged negatively. The amount of charge to make a capacitor, outer cell will have total charge minus Q and the inner cell will have plus Q. Now we know that if plus Q charge, the field lines will be away from the charge, so we can consider the field lines. These are the electric field lines. We can consider one hypothetical Gaussian surface here. Let's say this is the hypothetical Gaussian surface of radius r, which will completely enclose the inner sphere. Then we can find out the electric field linked with this Gaussian surface by the simple mathematics of your Gauss law, that E dot dA, this is your flux, is equal to, also from Gauss law you can write the Q enclosed by epsilon naught. So from here your E area is, of course, what is the area of a sphere? The area of a sphere is 4 pi, here our radius is r, Gaussian sphere, 4 pi r square. So E area will be 4 pi r square and Q inside, that plus Q, total charge inside that Gaussian sphere, that is your sphere having radius A. So in the surface of the sphere, plus Q charge is there, so Q inside will be Q by epsilon naught. So from here you can find out E, electric field, that will be Q by 4 pi epsilon naught r square. This is your electric field. But this is not our target to find out the field. Our target is to find out capacitance, because here instead of two plates there are two surfaces, one spherical surface outside, the another one spherical cell which is, or spherical solid sphere inside, and in between let's say air is there. You can put the dielectric also, we are not going into that. First we are finding out the capacitance. Now we are interested to find out the potential, because we are interested to find out the capacitance. For that we need C equal to Q by V. Potential, we need the potential. This is minus Q, this is plus Q, so there is potential difference, and we know that the work done against the field is potential difference. So we can write V equal to E dr integration minus, right, because we will go against the, we have to move against the field to store the potential energy or potential. So that's why the potential is E dr negative, and the integration you can say will go from outer to inner against the field. So B to A, we can write B to A, the outer shell to inner shell, we are moving like this from here to here. Now E we have already calculated, so it will be E dr. E and dr, r direction is same, and they are E dr cos, so it will be E dr. So E, this is Q by 4 pi epsilon naught r square dr minus b to a. So how will you integrate? You will integrate like this. Here dr by r square. So q fix 4 pi epsilon naught constant. Let us bring it outside. Q by 4 pi epsilon naught integration b to a minus, of course, and what is integration of dr upon r square? Basically it's okay, let me write b to a. You can directly write if you remember, or you can write r to the power minus 2 dr. So you can put the power formula n plus 1 by n plus 1. So basically it will become minus q by 4 pi epsilon naught. It will be r to the power minus 1 by minus 1. It will be b to a. So you can write your v equal to minus q by 4 pi epsilon naught. This is minus 1 upon r basically, b to a. Now we'll put the limits. So this is minus, you can take outside also, or you can keep it also, 4 pi epsilon naught. First you will put minus 1 upon a, minus minus plus 1 upon b, again minus will be multiplied. So basically it's q by 4 pi epsilon naught. This is 1 by a minus 1 by b, which you can write q by 4 pi epsilon naught. This one is b minus a, ab, LCM ab. So this is your v. This is your v. Now we can find c, that is our q by v. So v, this part will be denominator, this part will go to the numerator. So q b minus a, and numerator 4 pi epsilon naught ab. Or you can write your c equal to q cancelled out, 4 pi epsilon naught ab by b minus a. B, remember b here we have taken the outer shell, the outer sphere. A we have taken the inner sphere. So the capacitance is coming as your 4 pi epsilon naught AB, the products of the radius of the cells and the difference of the radius. This is how your capacitance for a spherical capacitor is coming up. And we have discussed about parallel plates, we have discussed about cylindrical capacitor, we have discussed about spherical capacitor also, and some of the numerical also will be doing, series, parallel, combination, networks. Then we'll be starting out the third chapter, current electricity. Thank you for watching. See you in the next video.